WHONET Training Course, Module 4, Introduction to Data Analysis. In WHONET, there are two kinds of analyses. Interactive analyses, where you choose the analysis details, such as the organisms and isolate filters. And two, quick analysis reports, where the analysis details have been previously defined, either by the WHONET team in Boston or by your local WHONET users. In Module 4, we will review the steps required to run an interactive analysis, while in Module 5, we will turn our attention to the objectives of each type of analysis and the interpretation of results. In Module 6, we will review the quick analysis reports. Module 4. We will cover 4 topics. A. Selecting the analysis parameters required to do an analysis. B. Running the analysis. C. Selecting optional analysis parameters. And D. Macros. After you begin WHONET, you will see the screen. I will click on WHO Test Laboratory and then Open Laboratory. On the WHONET main menu, I will click on Data Analysis to show that there are 2 options. Data Analysis, which is for interactive data analysis, which will be the focus of this module, and Quick Analysis. Use of quick analysis reports will be discussed in Module 6 of this training course. When I click on Data Analysis, I arrive on the WHONET Data Analysis screen, and I can see the required questions highlighted in green. I can indicate the analysis type, the organisms that I want to study, and which data files to analyze. I can also select whether to output the results to the screen or Excel or other option. In the next screen, we will review each of these 4 sections. After answering these 4 questions, we can then begin the analysis. We will start with a review of the options under Analysis Type. When I click on Analysis Type, I see the 6 kinds of analyses at the top of the screen: isolate listing and summary, %RIS and test measurements, scatter plot, resistance profiles, microbiology alerts, and cluster alerts. In this first analysis, I have selected the option for %RIS, and then I click on OK to return to the previous screen. We will now select the organisms to include in the analysis. On this screen, you will see the options available to you on the left of the screen, and on the right, we will indicate our selections. In this example, I have clicked on Staphylococcus aureus on the left of the screen, and I use the arrow in the middle of the screen to move it to the right. Alternatively, if I know the code of the organism, I can enter it into the box labeled Code and hit Enter. For example, the code for Staphylococcus aureus is SAU. On this screen, we can look at the use of the search feature to find organisms. In this example, I have entered E. coli into the search box, and WHONET shows to me a list of all organisms that match, including Entamoeba coli and multiple varieties of Escherichia coli. I can use the arrow button in the middle of the screen, or I can double-click on Escherichia coli in the list to move it to the right of the screen. On this screen, we can see that there is a useful option called Organism Groups. Instead of choosing a specific species, such as Escherichia coli, I can use this feature to select all gram-negative organisms. On this screen, we see an option called Analyze as one organism. With this option, we can merge the results of several organisms together. It would not be scientifically meaningful to combine the results for Staphylococcus aureus and Escherichia coli together, but this feature would be more relevant if I would like to average the results for several species of Klebsiella together. After you have finished selecting your organisms for analysis, then click OK to return to the previous screen. We will now review the selection of the data files to include in the analysis. On this screen, I can see the available data files in the middle of the screen. Specifically, WHONET is showing me files that include the laboratory code in the file name. For example, the code of this laboratory is TST. Therefore, WHONET is showing me data files that include TST in the file name. On the right, you can see a list of data files that will be used in the data analysis. You can use the arrow keys in the middle of the screen to move data files from the left to the right. You can choose a single data file for the analysis or many files. In this example, you see two files in the middle of the screen. The first file is from January 2000 with 1 month of human health data from a small community hospital. The second file, labeled as One Health, includes samples of human, animal, food, and environmental origin. We provide these files for purposes of teaching and practice. For this presentation, I have selected the first file with 1 month of human data from January 2000. In the previous screen, I was able to see a list of files from the WHO test laboratory. On this screen, you can see that I have changed the file filter so that I can see all data files ending with SQLite. This allows me to see data files from many laboratories. I currently see files in the WHONET data folder, but you can use the controls on the left to navigate to other folders. For purposes of this demonstration, I will only use the one data file that I have already selected, but the ability to select files from multiple laboratories is a valuable feature for national data managers. Finally, I can indicate the output destination for the analysis results, for example, Screen or Excel. For this demonstration, I will select Screen. On the screen, you can see that I have answered all of the required questions. I have selected the %RIS analysis with Staphylococcus aureus and Escherichia coli, with 1 month of data from the WHO test laboratory. Section B, running the analysis. I have previously answered the required questions. I can now click on Begin Analysis. When the analysis is complete, WHONET shows me the analysis results. At the top of the screen, I can see that there were 86 isolates of Staphylococcus aureus. Below this, I can see the results of the %RIS analysis. In the table, we can see the antibiotics that were tested for Staphylococcus aureus, as well as the % resistant, intermediate, and susceptible. For example, 79.1% of the isolates were resistant to penicillin, and 11.6% were resistant to the cefoxitin disc. In other words, nearly 12% of the Staphylococcus aureus were MRSA. At the bottom of the screen, we can see the graph with these same statistics for the % resistant to the antibiotics tested. This is a brief introduction to the %RIS analysis. We will discuss other features of the %RIS analysis and its value in Module 5 of the training course. The analysis results are interactive. On this screen, I have clicked on clindamycin to see the distribution of disc diffusion zone diameters for clindamycin. In this graph, we see the susceptible bacteria, which appear to the right of the red vertical lines, while the resistant bacteria appear to the left of the red vertical lines. It is also very simple to sort the table. For example, if I click on the column heading Antibiotic Name, the table is now sorted by in alphabetical order by antibiotic. This screen shows another analysis option regarding hidden columns. WHONET generally will show you the columns that are of greatest interest to most users. WHONET automatically hides columns that are of less interest. But there may be information in these columns that might be useful for some people. For example, I have clicked on Show Hidden Columns below, and I can now see that ciprofloxacin belongs to the quinolone class of antibiotics and the fluoroquinolone subclass. Now that we have seen how to explore the analysis results on the screen, we will now review how to transfer the results to other softwares such as Excel, Word, or PowerPoint. In this example, I have clicked on Copy Table from the top menu. And then I opened Microsoft Excel, and I selected Paste to transfer the results of the %RIS table to Excel, as you can see in the lower left. I then clicked on Copy Graph, and then I pasted the graph into PowerPoint, as you can see in the lower right. Instead of using Copy and Paste, you can also use Save Table and Save Graph to save the results to a file. In the lower left, I have saved the RIS results to Excel, and in the lower right, I have saved the clindamycin graph as a JPEG file. WHONET does offer a few options for modifying the graph. Find this feature, click on File, Graph Options, or you can right-click on the graph. When you click on Graph Options, you will see the screen in the middle where it has a title of clindamycin, and the color is blue. On the right, you can see that I have changed the title of the graph to Staphylococcus aureus clindamycin, January 2000, to give more information about the graph. You can see that I have also changed the color from blue to green, and I have changed the highest value on the vertical axis from 60% to 40%. When finished, you can click on OK. When you are finished reviewing the results for Staphylococcus aureus, you can then click on Continue to proceed with the next organism, Escherichia coli. You can now see the %RIS results for Escherichia coli. Instead of clicking on Continue multiple times, WHONET also offers a convenient option on the File menu called Stop Analysis. If you click on this option, WHONET will immediately return to the main screen for data analysis. We have seen how to select the required analysis parameters, and we have seen how to run the analysis. We will now review some of the optional analysis features. As you can see in the green box, there are additional options on the data analysis screen. There are options labeled Options, One per Patient, and Isolates. I will look at the feature for selecting specific isolates. Using the filters for specific isolates, you can define selection criteria for specific patients, locations, specimen types, or test results. For example, identification number equals 12345, animal species equals chicken, and imipenem equals resistant. When I click on isolates, WHONET will show me a list of all of the WHONET data fields. In this example, I have clicked on location type. Then at the bottom of the screen, I can click on Define Criteria, or I could also double-click on location type. When I do that, WHONET allows me to select the location types that I would like. For example, inpatient, inpatient non-ICU, intensive care unit, or intermediate care unit. You can include these values or exclude them. When you finish, click on OK. I can do the same with the antibiotic results. In this example, I have selected cefoxitin. In this example, I have requested isolates that are resistant to the cefoxitin disc. When I return to the main analysis screen, I see the two selection criteria for location type and cefoxitin resistance, which will give me a list of MRSA from inpatients. I can now click on Begin Analysis. I can see the results of the analysis. There are 7 isolates of Staphylococcus aureus from inpatient locations that are resistant to cefoxitin. For example, you can see that 100% of the bacteria are resistant to cefoxitin because this was my selection criterion. You can also see that 100% of the isolates are resistant to penicillin and clindamycin, and 71.1% are resistant to ciprofloxacin. You can also remove the filters when you no longer need them. In this screen, I have returned to the list of selection criteria. At the bottom, there are two options: clear this criterion or clear all criteria. For now, I will click on clear all criteria. Then when I click on OK, WHONET will remove the criteria. By default, WHONET excludes results from quality control specimens and screening samples because they do not represent clinical disease. If you would like to include these results in your analysis, you can turn off these exclusion criteria by unclicking the checkbox. If you define multiple criteria, by default, WHONET will select samples that meet all of the criteria. For example, female and urine and outpatient. But you can change this so that WHONET selects samples that meet at least one of the criteria. For example, if I would like to select carbapenem-resistant gram-negative organisms, I can search for isolates that are resistant to imipenem by either the DISC test or the MIC test, or to meropenem, resistant by either the DISC test or the MIC test. Below, you see those two features: include isolates that satisfy all of the selection criteria, or isolates that satisfy at least one of the selection criteria. We will now look at the option called one per patient. It is common for human patients to have repeated isolation of the same microbial species on different days, in different specimen types, and in different patient care area. This can also happen in diseased animals, but this is less common. It would also be rare to have repeated samples from healthy animals, food products, or environmental samples. People often use the term duplicate isolates when discussing repeated isolations of a particular species from a patient. In WHONET, we generally avoid using the expression duplicate isolates, which would suggest that the isolates have identical phenotypes, which often is true, but often it is not true. The resistance characteristics of the repeated isolations may be identical, similar, or very different. Identical results. This suggests that there are repeated isolations of the same microbial clone, perhaps on different days and in different body sites. Similar results. This could imply that there are repeated isolations of the same clone, but with small issues of test reproducibility. It can also imply that the clones are genetically related, but with some mutations which distinguish them. Very different results. This would generally imply that the patient is infected with genetically unrelated strains, though multiple mutations from a single strain or plasmid acquisition is also a possible explanation. Management of repeat isolates. WHONET offers three approaches for the handling of repeated isolations. 1, by isolate. 2, by patient, and WHONET offers several ways to do this. And 3, by episode, which can be defined by time intervals in between isolates or by resistance phenotypes. By isolate. I can select all isolates as you see on the screen, and all isolates are considered equally. This approach allows you to look at the workload of the laboratory. For example, how many Escherichia coli were tested. It is also useful for the identification of priority strains and rare resistance. However, if you prepare aggregate statistics using all isolates, you will usually overestimate the percent resistance, since patients with many repeat isolates often have greater resistance. It is also not appropriate for the detection of possible outbreaks. Five isolates of Pseudomonas during 1 week from 5 different patients might suggest a disease outbreak, but 5 isolates from the same person do not represent an outbreak. The second option is by patient, and WHONET offers several options. You can choose first isolate only, which is recommended when analyses do not address antimicrobial resistance. For example, how many patients in the database have Escherichia coli? There is also an option for selecting first isolate with antibiotic results. This would be recommended for studies of antimicrobial resistance, such as the preparation of antibiograms. For example, what is the percentage of isolates that are resistant to ampicillin? The advantage of doing analyses by patient is that you decrease biases in estimates of resistance rates. This is important for the development of treatment guidelines and important for monitoring trends. A challenge to the use of analyses by patient is that you need a reliable and unique patient identifier that the patient maintains over time. Unfortunately, many laboratories do not have a system for unique patient identifiers. Another disadvantage of doing analysis by patient is there might be interesting strains which might be excluded from the analysis if you only include the first isolate in the statistics. A table with the annual antimicrobial statistics is often referred to as an antibiogram. One of the most common uses of antibiograms is guiding recommendations for the initial empiric therapy for patients who do not yet have any microbiology results to support recommendations for empiric therapy. With this objective, the recommendation from the CLSI M39 document and others is to prepare the antibiogram using the first isolate per patient per species. It is clinically meaningful for decisions on empiric therapy. It is also the simplest recommendation for data analysis for preparing antibiograms in a standardized way. A final option here is to remove isolates on the basis of the time period or resistance phenotype. For example, how many episodes of bacteremia with MRSA were there in hospitalized patients last year? An advantage of this approach is that it is valuable for the infection control team for monitoring episodes of infection. It can also be used to track strains with different resistance characteristics. The challenge to this approach is that there are no standard definitions of what we mean by an episode, and such definitions would need to be modified for different organism groups and different clinical scenarios. For purposes of empiric therapy recommendations, it will usually overestimate resistance rates because patients with multiple episodes are often patients with higher rates of resistance. We will now discuss a few final options available in data analysis. When you click on options, you will see a few features. For example, you have the ability to combine DISC, MIC, and e-test results. This particular feature is useful in two situations. If an isolate is tested by more than one method, then WHONET can combine the results into a single interpretation. The user can also indicate the priority of each method. By default, the e-test result will take precedence over the MIC result, which will take precedence over the DISC diffusion results. But the user can change this. 2. This feature is also useful for combining data from different laboratories in a national network. For example, if some laboratories use the DISC diffusion test while other laboratories use MIC tests, you would like the national aggregate statistics to combine the results from both methods. Slide 53. There is also a feature here for encrypting patient information. This feature is useful for analyses which include an isolate listing, such as the isolate listing and summary, resistance profiles, isolate alerts, and cluster alerts. You can delete or encrypt confidential information, such as patient names, identification numbers, and dates of birth. These options will be described further in a different module. The encryption features are particularly valuable if you would like to share data with external partners, but without sharing confidential patient details. Finally, we will talk a bit about macros. WHONET users often wish to repeat the same set of analyses on a regular basis. For example, daily, weekly, monthly, quarterly, and yearly. They may want to have different analyses for different audiences: laboratory staff, infectious disease specialists, the infection control team, the pharmacy, national authorities, and funders. The purpose of macros is to permit you to repeat analyses that you have done previously. The macros will remember the options that you have selected for analysis type, organism, isolate filters, data files, and other parameters that you have selected. You can repeat the analyses on the same data file, or you can run them on new files from the same laboratory or from other laboratories. There are several benefits to using macros. Macros save time and promote consistency with repeated analyses. There's no need to remember the details about which organisms and other analysis options were selected. One WHONET user can create macros and reports for other WHONET users, which promotes standardization and collaborative discussions of results, both within a single institution and across many institutions. WHONET macros can also be bundled into a report. WHONET reports will be covered in Module 6 of this course. Finally, WHONET macros can be scheduled to run automatically, for example, daily, weekly, or monthly. The WHONET automation tool will be discussed briefly in Module 6. To create a macro, the first step is to choose your analysis parameters. In this example, I will create a new analysis. Note, remove automation from the slide. We'll start slide 57 over. To create a macro, the first step is to choose your analysis parameters. In this example, I will create a new analysis. I'm now in data analysis, and I have chosen the analysis for %RIS for Staphylococcus aureus and Escherichia coli. I have also selected a data file, and I have chosen the feature first isolate per patient with antibiotic results. I can then begin the analysis and review the results on the screen to ensure that the results match my expectations, as in the lower right. Slide 58. After I define the details of my analysis, I am now ready to create my macro. Click on Macros to get the screen on the below left. I can then click on New. In the screen below in the middle, I have entered a name for the macro, %RIS for SAU and ECO, first. I then click on Save. Below right, WHONET then asks me to give a name to the macro file, suggesting %RIS for SAU and ECO, first.mcr. Click on Save. By default, your macros will be saved in the WHONET macros folder. After you save the macro, note, remove automation. Starting the slide again. After you save the macro, we see a list of all of the macros that you have created. From here, you have the options of New, Load, Edit, and Delete. You can also click on Browse if you would like to find macros saved in another file location. Now that you have created a macro, it is very simple to use. Go to WHONET Data Analysis and click on Macros. You will see a list of all of the macros that you have defined, as you see in the lower left. Choose the macro that you would like to run and click on Load. WHONET will then read the analysis details saved in the macro and display them on the screen, as you can see in the middle image. You can now click on Begin Analysis to get the results, as you can see in the lower right. Before beginning Begin Analysis, you can also change some of the details before starting the analysis. For example, you could modify the list of organisms or data files. Once you have created a macro, you do have the ability to edit the macro manually. For example, to add more organisms or filters. This is useful for local and national data managers responsible for creating multi-component analysis plans. You can edit your macros with WHONET, or you can also use Windows Notepad. On this screen, we will review the steps for editing a macro using WHONET. I go to WHONET Data Analysis and click on Macros. WHONET will show you a list of all of the macros as you see in the lower left. Click on the macro that you are interested in and click Edit to get the screen that you see in the lower right. You will then see the parameters that are defined for the macro. For example, analysis equals %RIS and organisms equals SAU and ECO. If you want to make changes, click on Edit and make the desired changes. When you finish, click Save and Exit. You can then use Windows if you want to update the name of the macro file to reflect the modifications that you have made. You can also edit the macro directly with Notepad or other text editor. By default, WHONET macros are saved in the WHONET macros folder. Find the macro that you wish to edit and open it as you see in the lower left. If you open the file with Notepad, you can make the edits that you wish. You can also make copies of your macros and then manually edit the copies. Once you have made macros for yourself, you can also share these macros with others. By default, the macros are stored in the WHONET macros folder. From here, you can make backup copies or send copies to your colleagues by email. Macros generally do not have confidential information in them, so you can freely share them with collaborators. On rare occasions, there might be confidential information in a macro. For example, if you have created a macro with a filter based on a patient name. I mentioned previously that the macros are saved by default in the WHONET macros folder. You can change and select a different location on your computer if you prefer. For example, you can select a location on a central server. In this way, multiple staff members can share a common set of macros. To change the default file location, go back to the WHONET main menu. Click on File and click on Configuration at the bottom of the screen, at the bottom of the menu. You will then see that the macros are saved in the WHONET macros folder. You can click on Browse and then choose a different file location on the local hard drive or on a central server. Introduction to Reports. In this module, you have seen how to create individual WHONET macros. In Module 6, you will see that we can bundle many analysis macros into a single user-defined report to have one report that does many different analyses. Thank you for watching Module 4. Next, Module 5, Data Analysis and Interpretation. Thank you for your time.